Okay, so let us now use Pascal's triangle in expansion of algebraic what? Expressions. Example 1. Expand a plus b to the power of 2 using Pascal triangle. Yes, we are now in the real thing, okay? This is a real thing now. How do we use Pascal triangle to expand a plus b to the power of 2? It's obvious, we know that a plus b squared is the same as a squared plus 2ab plus b squared. We know this, okay? But I want us to start using Pascal's triangle as early as possible so that we shall be able to solve or expand expressions of higher order at a later what? At a later time, okay? So Pascal triangle focuses on using coefficients, okay? If you recall the coefficients, we said if you have 1, you're going to have 1, 1, and you have 1, 2, 1, 1, 3, 3, 1, and so on. So we say that this is for a plus b to power 0. The second one is for a plus b to power 1. The third one is for a plus b to power 2. And the fourth one is for a plus b to the power of 3. In this case, we're having a plus b is equal to, a plus b to the power of 2. So how are we going to use Pascal's triangle to expand this? This is what you need to know, okay? If you have a plus b to the power of 2, now this is what you're going to do. What you need to know is that the number of terms a plus b to the power of 2 has what? 3 terms. What are those terms? We have a, b, we have another a, b, we have another a, b. Those are the 3 terms. The task we have is to indicate here the coefficients and the powers of the terms. Now, from our Pascal's triangle, we know that in a plus b to the power of 2, the coefficients are 1, the second one is 2, and the last one is 1. Okay? Very interesting. So those are the coefficients. If you look at this, look at here. The coefficient here is 1, the second one is 2, and the last one here is 1. Those are the coefficients. The coefficients are those constants. Now, how do you get this 2? How do you get this 2? B to power 2. Yeah? How do you get this 2? The power 2, the power 2 for B. This is what you do. The rule here is that if you have here a power and you have here a power, when you add those two powers, they should be able to give you this. The sum of the powers of a term will always be equal to the power of the expansion. So the expansion is to the power of 2. So it means that if I choose to start here with 2, a to the power of 2, it means that b should be 0, such that 2 plus 0 will give us 2. In the second term, in the first term, a was to the power of 2. But now in the second term, a will reduce by 1. So 2 minus 1 will become 1. B was 0. So in the second term, it will become 0 plus 1. It will become 1. Now when you add 1 plus 1, still you'll get 2. 0 plus 2, still you get 2. In the third term here, A will again reduce by 1. So in the second term, it was 1. If you again subtract 1 minus 1, it will now become 0. And finally, B will increase by 1. So 1 plus 1 becomes 2. Okay? The rule here is that the powers, the rule here is that the power of A decreases as you move from left to right. Okay, that is the first rule. Okay. Secondly, if you look at B, the power of B increases by 1 as you move from left to right. Okay, that is rule what? Rule 2. Even the power of A decreases by 1, also put here by 1. The third deduction is that the sum of the powers of A and B will always be the same. Okay, these are the 3 rules that we are applying in this. So what does that now tell you? This is what it will tell you. If you simplify this, okay, if we choose to simplify this, it will give us this. A, it will give us 1A squared. B to the power of 0 is 1. So there's nothing like again writing anything. Anything to power 0 is a 1. Then we add 2AB. Why? Because there is a silent power 1, silent power 1. Okay? Then we have plus the last one 1b squared, because a to power 0 is a 1. And this now simplifies to a squared plus 2ab plus b squared. Now you can see that this is the same as this. Okay, it is the same as that. These two are the same. You've seen that. So this Pascal triangle. With Pascal triangle, you're going to have AB, AB, AB. Then using these rules, the rule is the power of A decreases by 1. It decreases by 1 as you move from left to right. Rule 2, the power of B, these powers here, this one, from 0 it will go to 1 to 2. But for A, it will start from 2 to 1 to 0. Why does it start from 2? Because the power here is what? The power here is 2. Okay? So in our next lesson, we shall now be able to see how to apply Pascal triangle in expansion of other algebraic what? Expansions of higher what? Of higher orders. I thank you so much. Let us meet in our next what? In our next lesson. Thank you so much.